Happy Wednesday, hackers. Hope everyone's doing well. So I thought tonight, since it's been a minute since we've done some straight up programming, that we could do some practice on some Rust. I haven't had a chance to do a lot of programming recently because I've been doing, actual security stuff, but I do love it so much. So let's do it. We're starting here in CodeWars. If you're not familiar with CodeWars, it's a very cool gamified practice site for programming languages of all stripes. Let's look at the different languages we have for this challenge. If you wanted to do it in Crystal, you could. Haskell, JavaScript, I'm specifically not mentioning Java, Python, Ruby, and Rust. But we're going to do it in Rust just because that's kind of been my jam for a little bit. And so what do we have here? Our job is to take this string of characters and replace all but the last four with hashtags or pound signs if you're over 20. So let's there are a couple of ways that we could do this. There are a lot of options here. So obviously the first thing we need to do is we need to return a string. That's what we have from our function signature here. So let's get rid of the panic and let's just put in, let's say let mute res, because we're probably going to have to, mess with the resulting string. But let's make a new string, just like that. Okay. And we'll return res by just invoking res without a semicolon, and Rust returns the last statement in a function without a semicolon. All right, so what we should get is failures, but we should get failures of the type that left does not equal right here in our tests, rather than failures of syntax or any other kind. And indeed we do. And we're also getting an unused variable, but that's fine. All right, so what do we want to do? We know that we're going to make a new string. Easy could be just like, we could do string from CC, and then it would say that the left is the credit card number and the right is, should be everything hashtagged or pounded until 5616. Let's try that. Right, so now we have the whole thing coming in. The trick is that we actually need to get at the individual characters in here, right? And so it actually might be more work than we want to start from that string, rather than doing something else with that string. So we'll do this procedurally. I think there's probably a cool functional way to do it, but, procedural is pretty simple here. What we would do is for yeah, 0 to cc.len. So what we're doing is we're getting the length of the CC string primitive, and we're using that as kind of our stopping point. And we'll really easily say, if I is greater than or equal to cc.len -4, so we're -5, because we're got to do a -1 to make the difference between the length and the actual final index. If it's 4 from the end, right, we're going to do something else. We'll say res.push, and push takes a character, which in Rust we do with single quotes rather than double quotes. They actually make a difference in Rust. And otherwise, we'll do else. We'll say res.push Get, right? Slice index. I can already see that there's going to be a cleaner way to do this here, but we'll do it this way first. But we're going to get is that push cc.get I dot unwrap. Let's try that. Why do we need the unwrap? Because the get method, which gets the subslice, actually, can I just do this with basic indexing? We'll find out. Let's see what this does. Nope. Oh, this needs to be string new, not from, because I emptied it out. The type store cannot be indexed by usize. Really? What does it want? U32? Oh, no. I bet it's, it has to be signed. Oh. What's a dereference? Interesting. Let's look at slice index. Let's try it that way. Problem here is that I needed to create a reference, so... Oh, that's got to be I+1, because it's not inclusive. I did the opposite. Well, that's just a sign flip. Attempt to subtract with overflow. Oh, I did a dumb math, didn't I? Yup. Right. So what we'll do is we'll flip the operations here. Put that there, put that here. And... if I is greater than, not greater than or equal to. It's so funny why that -5 works, but -4 doesn't. If I is greater than or equal to the length -5. Oh, I think it's failing on a different test. I think it's failing down here. All right, so we need to reframe the problem a little bit. If the length is greater than 4, then we do everything beyond 4. Starting from the right. Maybe that's a cleverer way of thinking about it. Basically... I think we can reverse this pretty easily, right? I think there's a reverse capability in here. Is this rev? Yes. Hmm. So I could nest this inside of another conditional, but that's going to be messy. This shouldn't fail just because. I'm going to make it print out the thing that it's failing on, because I don't think... Yeah, see? The first one, it worked okay. The second one, it didn't. Let's empty a subtract with overflow. So let's see what that's all about. Let's try this another way. Let's get the cars. Which returns an iterator, and it's not an option, so it just becomes that. Okay, cool. So we'll do now. Here we go. Here we go. And we can reverse this, right? Yes. Cars is an iterator, which means that we can reverse it. If res.len is less than or equal to 4, then we're going to res.push C. Probably need to reference it like that. Else res.push £, and then we're going to return. What can we do with reversing strings? Because that's the thing we actually need to reverse. We can reverse it, but can we collect it back into a string is the question. Let's try it. Cars dot rev, right? And then we collect to turn it back into a thing. Unbelievably, that's working. So the trick here was that if we were doing iteration like this, right, the C was signed, it had to be positive. Or sorry, it was unsigned, meaning that it had to be a positive value, right, an absolute value. And unfortunately, our attempt to subtract before to get the difference between the beginning and the end was turning shorter strings negative, so that didn't work out. So the way we got around that problem was we're always moving forward. So we're just saying, okay, we're going to build the string from right to left, and then we're going to flip it. That's basically the idea. All right. Now, is there anything we could have done to clean this up before we move forward? I don't think so. Because I don't think if we look at iterators. See, if this were in JavaScript, I could do some cool stuff with it, but I don't think I have fun stuff. Yeah, see, the Rust implementation of fold doesn't have extra arguments that are coming into it. Whereas in JavaScript, for example, you get all sorts of crazy stuff in the iterator methods, like the current index and the entire array is coming into it, which we could have used to test length as we went. But in this case, I think we're pretty clean here. So let's go ahead and submit that. Interesting. So you're making use of the repeat. It's kind of cool. It's making use of format. This is what I was trying to avoid. casting the types. Okay. A little bit more work than I needed to do because of repeat. But now we know. This match right here is actually the real trick. This is good. I should have done that. Alright, what's next? Absolutely not. We've done this one before. Let's try another 7. In Rust, please. Grid index. All right, give it a shot. "31 out of 978 have completed this one. You are given an n by n square grid of characters. Is also given a list of integers and is input. You have to find the characters in these indexes of the grid if you think the indexes are." Okay. Let's do it. Okay. So this type notation is maybe a little bit confusing at first. What we're getting in as a grid is a slice or a vector of vectors, right? Or a list of lists, if we want to put it that way. I gotta change this music. Too cool for me. Let's go to some lo-fi, just so it's a little bit easier to think. Very nice. Okay. So we're given, this is our grid. And then we're given a list of integers. 1, 3, 5, 8. And we have to map it onto this. 1, 2, 3, 4, 5, 6, 7, 8, 9. The question is, what's the most efficient way of getting to a grid square, given a single index, right? So for 5, we know that it's 9 long, 3 wide. So the index, yeah, so the length of the grid is going to be how many rows there are. Now it's using... Oh, actually, you know what? They're giving us a hint here that they're always square grids. That is handy. Because if we do, like... If we do the length mod the index, do we get anything interesting? No, we don't, right? The length of rows, though, let's see. 3, 5, 3. This is 2, and then... Is it the case, and this is just me being horrible at intuitive math, is it the case that the coordinate is the x coordinate the or sorry, the y coordinate is the grid length mod the index? And then similarly, is it the case that the x is the row length, whatever that happens to be, right? Which is, by the way, the same thing as grid.len because they're squares. So grid.len. Is that true? Is that always going to be true? So it's true for 5, right? So if I do 5, right? The length of the grid, meaning the number of rows, is 3. So if I do... Oh, it's actually I mod that. Sorry. So if I do 5 mod 3, it gives me a remainder of 2, right? Which is the second row, and then it's also the second column. But no. That won't work. So let's try it for 8, for example. So let's try... So 8 mod 3 gives us, yeah, 2. That's not correct. Never mind. That's nonsense. But what is it? Is it 9 minus the difference? What if we do, like, the difference between the index and the length total, which is 9? I think that kind of gets us there, but in an interesting way. So what I'm saying is, if we take the length of the grid, right, which in our case is 9, and we subtract the index, whatever it is, right? We take that, and then we do a division by the length of the row, by the length of, I guess, the row. What we get is something like, in the case of 5, we get 1.333, which is actually correct, right? So it's 1 1/3 rows down, right? So it's one complete row and 1/3, and then there's that. So let's try it with 8. This isn't gonna work. Because it goes... Yeah. Unless... Oh, wait, you know what? It kind of does. Because it's going from the other direction, right? So if I give it 8, right? And if I do 9 minus 8, that's 1, obviously. Divided by 3 is 0.33 repeating. Meaning it's 1/3 of the way. It's 1/3 of a row back from the end. Okay, let's try it with another one, see if that makes any sense. So if we do 9 minus, let's say, 1. Let's try it 3. So 9 minus 3 is 6, divided by 3 is 2. And sure enough, we have to go 2 full rows before we get to here. And then it's just a +1. It's an off by 1 error, but I think we're... Interesting. So okay, so if we do it this way, the whole numbers are the rows and the decimals are the columns, right? Let's try 4. So if I do 9 minus 4, what I'm expecting is it should show me it's 1.66 repeating, right? Which it is. Okay, this is kind of cool. So what we're going to do is we're going to write a helper function, which is called derive ports. And we're going to give it grid len of usize and an index. That's all we really need, right? So let's call it delta equals grid len minus idx. Or I don't have a good name for this value. It's like a composite. That's plenty. Divided by oh crap. actually gridlen times gridlen, right? Because it's whatever the square of it is. Yeah, we'll do it that way. And then we have to somehow split yeah. Floor will do it, right? So will trunk. Yeah. Close there. Oh, I forgot to say what we're returning. Just two U sizes. You know, tuple. So we'll return composite dot because it's how many back we're going. That's still fine. So we'll do gridlen minus composite.trunk as U size, probably, right? Because trunk gives us a float. Yeah, we want to type that. And then we have to do... That's actually the... Yeah, that's the x-coordinate. And then the... No, sorry, that's the y-coordinate, right? Because it's the row number. Then, for the x-coordinate, what we need is... gridlen times... You know what, let's save that as a value, just so I don't have to keep on doing the computation. Composite.trunk. So we'll call that truncated. And here, for the x, we'll do gridlen times composite Mine is truncated. Whatever that is. Trunk. That's a lot. We could probably clarify that a little bit more. Oh, it's got to be an F-32 there anyway. Okay, so we've got composite truncated remainder, and then we'll do and all right. And let X equal this. We're going to return X and Y. I realized that was a lot, but what we should be able to do at that point is return grid. We'll say let coords equal derive coords with grid.len and oh, hold on a second. I forgot we're making a whole thing. For I in indices. Here we go. Let coords equal to coords I as use size, because that's actually might be use size to begin with. Okay, and then string dot push, not string, res dot push. We're gonna get grid, and we're gonna index it this way: coords dot 0, and then coords dot 1, right? Because they're nested lists or nested vectors. And return res. All right, we got many things wrong. Oh. The grid len is U size. The IDX is U size. Divided by a grid len. But I can't have it be an integer. Let's see if that does it. Okay, well, we got down to line 6 before we got an error here. So, no implementation for U size times F32. Sure. U size equals... So it's X. Getting closer. Just kind of throwing integer types around. Let chords derive chords. Expected U size found. Consider dereferencing the borrow. Oh, actually. Can I do that? Yeah, why not? Oh, did I ever use for the remainder? Did I forget to do something? Oh my god, I did. Yeah, I forgot to use it here. It's doing extra math. Oh, gotta mute res. Oh. I do have to do a -1 for each of these? Here we're doing. I want to see if the coordinates are even getting close to correct. Kinda. Well, let's see what the result is looking like as it goes. Okay, so not quite. Why, 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 why? So the whole idea was, if we take the difference between the length of the grid and the index. Okay, let's get rid of that printing for the moment. M2 should obviously be All right. Well, I will finish this some other time.